All huge automated respect. If you see this yellow and black spinning thing on your monitors, then you are watching the Automation for Dummies channel again. I'll start without a long introduction. In the last video, we discussed the principle of operation of the simplest valve control circuit diagram. You can see a link to it at the top of the screen. Today, as I said, we will try to simulate the operation of this circuit in order to see with our own eyes all the nuances of valve control. Well, let's try to write a program for the so-called valve simulator. To write the program, we will use the Unity Pro XL development environment. Unity Pro is a software environment for configuring, programming, debugging and diagnosing the executive system of Schneider Electric industrial controllers. Unity Pro supports 5 programming languages that comply with the IEC 61131-3 standard of the International Electrotechnical Commission. The IL language instruction list is a list of instructions that is executed sequentially, similar to assembly language. The LD ladder diagram language is a graphical programming language, which is a ladder diagram. The FBD function block diagram language is a graphical programming language that allows you to create programs in the form of functions, procedures and functional blocks interconnected by information links. Saint structured text is a text language like Pascal, C, BASIC and similar programming languages. The SFC language, sequential function charts, is a graphical programming language in which the system behavior is set by a sequence of steps, where the necessary actions are indicated, transitions between steps containing conditions. Here you can talk for a long time about all the features of the Unity Pro software package, but it will take a very long time. I'd rather talk about everything that I know myself as our project progresses, and for those who are interested, I already talked about this in one of my first videos, the link to which you see on the screen. The truth is only in Russian. Well, how this English version will turn out to be accessible and understandable is up to you, my dear viewers, to judge. Well, it seems to be enough for the entry. Well then let's go. So let's start Unity Pro. Now we need to create a new project. For this we click on the New Project icon, which is located in the upper left corner of the screen, or select New from the File menu. A menu appeared on the screen in which we can select the type of PLC, the model of the processor module and the type of chassis with the required number of slots. A slot is a footprint where the processor module and I/O modules will be installed. During the creation of the program, the selected parameters can be changed. At this point, let's select a Quantum 140 CPU 53414A, B/U controller and a 4-slot chassis. Press the OK button. Congratulations, our new project has been created. Now it needs to be saved. To do this, click on the icon with the image of a floppy disk and in the window that appears, come up with a name for our project and save it. I called my project Emitting Valve. So, our project is created and saved. Let's go further. Now that our project has been created, let's take a look at its hardware configuration. To do this, in the project browser, which is located on the left, go to the configuration menu. Our 4-slot chassis appeared on the screen. As we can see, the processor module we selected earlier is already installed in the second slot. To the left of it, in the first slot, there should be a controller power module. Let's install it. As we can see, the project browser has changed a bit. A drop-down list of available modules has appeared on top. We open the last item from this list, which is called Supply. In the list that appears, select the power supply module 140 CPS 11420 and drag it to the first slot. Now it remains to fill the third and fourth slots. At the initial stage, only discrete signals are present in our valve control circuit diagram, so we will put the discrete input module 140-74000 in the third slot. We find it in the same list in the discrete item, and similarly to the power module, drag it to slot 3. In slot 4 we drag the discrete output module 140-84000. Now we close the configuration window. We will finish it a little later. Well, let's go directly to programming. Let's remember what our valve control scheme is. Here's our scheme. It consists, as we remember, of buttons, contacts and relays. Therefore, it will be logical if we choose the language of ladder logic for programming, LD. In Unity Pro, the user program consists of sections, each of which can be written in any of the IEC 61131-3 languages. In order to create a section in the project browser, select the type of program MAST, that is, single tasking. What does this mean? Yes, to be honest, I don't know. I'm self-taught. Therefore, we will not go into such details. Inside the MAST folder, we find the Sections menu, right-click on it and select the New Section section. In the window that appears, specify the name and programming language for our section. In our case, select the LD language. I named my section simply Circuit. Click OK. That's it, our section is created. On the screen you see the workspace in which our program will be compiled. By default, the left side of the workspace is conditionally phase conductor L, and the right side is the neutral wire. At the top of the toolbar, we see different contacts and coils, with the help of which a program is written in the ladder logic language. Let's use them to try to draw up our valve control scheme. For convenience, you can temporarily close the project browser, so the workspace will expand to full screen. So, let's go in order. And the first element we have is the Stop button, or rather, the normally closed contact of this button. On the toolbar, click on the Normally Closed contact icon and set it to the workspace. Now we need to bind the corresponding variable to our contact. To do this, double-click on our contact and in the window that appears, write the name of the variable that we want to bind to this contact. Let's not invent anything, but let's call our contact the same as it is called on the SB1 diagram. We press the Apply button and we see that we have another window in which we are asked, create a variable, change the variable type from bool to ebool and click on the green checkmark. Everything. The variable has been created. In the first window, click OK, and now the variable SB1 is tied to the Stop button. Let's bring back the project browser and open the variable table in it. As we can see, our newly created variable is included in this table. So far, this is only one variable and we know that this is the Stop button, but when will there be many variables? In order not to get confused in them, let's write in the comments column in the variable table that this is the Stop button. Do the same for the Open button. We bind the variable SB2 to it. We write in the comments that this is the Open button. Well, now let's transfer the remaining elements of the valve control circuit to the workspace in a similar way. Now let's connect them in the right way using the connection lines that are in the same toolbar. Well, the valve opening circuit is ready. Let's bind the appropriate variables to its elements. Now we already know how to do it. So go ahead and with the song. Now we select the already finished part of the circuit, copy it and paste it into the workspace. Next, we connect both parts and replace the variables in the closing chain. Well, our program is ready. In LD language, it looks very similar to a real relay contact circuit. The status of normally open and normally closed contacts is controlled by variables of type eBool, which take the values true logical 1 or false logical 0. That is, if the SB2 variable acts on the normally open contact of the open button, then this contact closes if the SB2 variable takes the value true or a logical unit and opens if the SB2 variable takes the value false or a logical 0. And if the normally closed contact of the stop button is affected by the variable SB1, then this contact closes if the variable SB1 takes the value false and opens if the variable SB1 takes the value true. The connected contacts organize circuits connecting the conditional phase with the conditional 0 through actuating elements. Various types of coils or blocks, functional block, functions, etc., are used as actuating elements. Our program uses normally open coils that act on variables Km1 and Km2. If a conditional current passes through the coil circuits, then the variables associated with them take the value true, otherwise, if the current does not pass, the value false. The next step is to check whether the program we have written is working. In the Unity Pro environment, display and data input tools are available to test the operation of the user program. The means of displaying and entering data include animation tools of program editors in online mode, animation tables, operator screens. With the help of animated tools of the editors of user programs, it is possible to observe online the value of variables, the passage of a signal, and so on. Animation tables in tabular form, and operator screens in graphical form, allow you to observe and change the values of variables during the execution of the user program. In this video, we will use an animation table to debug the program. To do this, right-click on the Animation Tables folder and create a new animation table. The created table resembles a table of variables, but you can change the value of variables in it. To test the performance of our program at this stage, we need 3 variables SB1, SB2 and SB3. Let's add them to our animation table. Now we need to compile our project, that is, check it for errors. To do this, go to the Build tab and check our project. So no errors found. An important feature of Unity Pro is the ability to use the PLC simulator, which allows you to debug the operation of the user program without the existing hardware. The PLC simulator operates like a normal controller, except for certain limitations, using the resources of the computer and the Windows operating system. We start the controller simulator in the PLC tab. Next, we connect to the simulator and fill it with our program. Well, now you can test our program. Using the arrows in the animation table, we change the values of the variables. There, simulating the pressing of the buttons, we check the performance of the program. As we can see, the program works great. Well, I think that's enough for today. Let's make it harder next time, and now thanks for your attention. Subscribe to the channel. Goodbye.